Hello, Chemistry. Mr. McKee here with the next installment in our Stoichiometry series. Today we're going to learn how to convert from mass in grams of one molecule to mass in grams of another, which in some ways is simpler than the last thing we learned, because in our stoichiometry roadmap, we're going to be going from one side of the map all the way over to the other. So we don't really have to figure out where to start per se. We're just going all the way from the left to the far right. So let me walk you through the first example in the booklet. Here we have an equation showing tungsten oxide reacting with hydrogen to form regular old tungsten and water. All right. So step one, as always, is to carefully read the question and identify the important information in it. So this one says, use the equation and the molar masses of tungsten and hydrogen to calculate how many grams of hydrogen, that's what we're trying to figure out, must be used to produce 5 grams of tungsten. So that's what we've been given, is tungsten. So now we want to very carefully identify the portions of the equation that we're actually going to be using. Typically, you're only going to be using 2 parts of the equation. So we're interested in hydrogen, which is right here, and tungsten, which is right here. Of course, W is tungsten. All right, so now we're going to map out everything here. As I said, we're going to simply go from the far left to the far right. So we've been given tungsten, so we're going to start with the mass of tungsten, and we're going to use its molar mass to convert that into moles of tungsten. And then we're going to change from moles of tungsten to moles of H2. We're going to use our mole ratio from the equation, which you see up here is 3 to 1. And lastly, we're going to convert from moles of H2 into mass of H2 using the molar mass of H2. So that is our roadmap. Use that as your guide as you proceed. So since we're using the molar mass of both elements, we're going to have to calculate the molar mass of both elements. So let's do that. First of all, tungsten. This is just plain old elemental tungsten, so it's going to be very easy. All we have to do is look at the periodic table, and we see that it is 183.84 if you find W on the periodic table. Nothing to total up in this case. Very straightforward. Hydrogen is also pretty straightforward. We do have H2, so we need to put the number 2 here, and we need to multiply the mass of hydrogen from the periodic table by 2, and when we do that, we get 2.016 grams. So that is the mass of 1 mole of H2 in grams. So we're going to use those in our conversion factors, specifically in these portions right here. So let's get into our actual train tracks now. So we're starting with 5 grams of tungsten. Real important to label the elements in these problems and the compounds. And we're trying to convert to grams of H2. So we can go ahead and put grams of H2 in for our answer. So the first conversion factor is the one that's going to help us convert from grams of tungsten to moles of tungsten, and that is this relationship. 1 mole of W equals 183.84 grams of W. So that's our first conversion factor. Then we're going to have to convert from moles of tungsten to moles of hydrogen, and so we're going to use the mole ratio from the equation. So 1 mole of tungsten goes with 3 moles of hydrogen. And again, I got that by looking at the coefficients here in the equation for those 2 actors. Okay, finally, we need to convert from moles of H2 into grams grams of H2, so I'm going to use the molar mass of H2 as a conversion factor. I need to be careful and label what we're talking about here. So 1 mole of H2 is going to be equal to 2.016 grams of H2. All right, now we can plug everything in. And I actually recommend just putting your units in at the start and not worrying about the numbers. And you can use your roadmap to do that. So we've been given grams of tungsten, and so we're going to have to convert from grams of tungsten into moles of tungsten. That's our first step. And that will enable us to cancel out grams of tungsten. And then we're going to have to convert from moles of tungsten into moles of hydrogen using the mole ratio. And when we align it like that, we can cancel out moles of tungsten. And finally, we're going to need to convert from moles of H2 to grams of H2. And if we set it up like that, we can cancel out moles of H2, leaving us with that. So now we just have to plug our numbers in. So how many grams of tungsten from the problem? We've got 5.00 grams of tungsten. And then the molar mass of tungsten is 183.84 grams, and that's equal to 1 mole. And from the equation, we know that there is 3 moles of H2 for every 1 mole of tungsten. And finally, the molar mass of hydrogen, 1 mole of hydrogen is equal to 2.016 grams. So now we just have to times on top and divide down. And we're going to do that in one process, only hitting enter once. So the way you do this is you start with the number 5, multiply it by 3, multiply that by 2.016, then we're going to divide by 183.84, then we're going to hit enter, and that's going to give us our answer, which is when you round it, 0.16 grams of H2, not very much. Okay, pause the video and do the U-try. Welcome back. Hopefully you were successful with the U-try. Here is the solution. Step 1 again is to read the question carefully. I can't emphasize enough how important that is. It says use the same reaction and conversion factors in the example problem to calculate the mass of tungsten oxide required to react with 250 grams of hydrogen. So you got to be very careful here. Tungsten oxide is something different. It is this, and we're still using hydrogen, so we're just focused on the reactants. And for this question, we can ignore the products. So we're trying to figure out what ratio there. So we've been given grams of hydrogen. So we first have to convert to moles of hydrogen. And then we got to convert from moles of hydrogen to moles of tungsten oxide. And finally, from moles of tungsten oxide to mass in grams of tungsten oxide. So that is our roadmap that we want to keep coming back to. So we're going to need to calculate the molecular mass for both of these. We know that hydrogen from the last problem is 2.016 grams. Okay, and we've got 2 hydrogens of 1.008 grams. And tungsten oxide is going to take a little more work. We've got 1 tungsten in here and 3 oxygens. So the mass of 1 oxygen is 15.999 grams, so make sure that you multiply that by 3, and then you add that to the mass of tungsten, and when you do that, you should get 231.84 grams. Okay, we're going to use those for conversion factors as we move on. on here. So remember, we're interested in these portions. We can ignore the products for this particular question. Our starting number was 250 grams of hydrogen. And we're trying to figure out how many grams of tungsten oxide would react with that. So going in order, step one is to convert from grams of hydrogen to moles of hydrogen. So the relationship we're going to need is 2.016 grams of hydrogen is equal to 1 mole of hydrogen. So that's our first conversion factor. Then we're going to have to convert from moles of hydrogen to moles of tungsten oxide. So the relationship we're going to need there is 3 moles of hydrogen is equal to 1 mole of tungsten oxide. And again, I got that ratio right here in the equation, 3-to-1 ratio. Finally, our last conversion factor in this 3-step problem, we're going to have to convert from moles of tungsten oxide to grams of tungsten oxide. So we're going to use the number we calculated up here, and that is going to be 1 mole of tungsten oxide is equal to 231.84 grams of tungsten oxide. Notice I'm being careful to label everything. So I'm going to set everything up down here with the units, not even worry about the numbers initially. We're starting with grams of H2. We need to convert from grams of H2 into moles of H2. And then we're going to convert from moles of H2 to moles of tungsten oxide using our mole ratio. And then we're going to convert from moles of tungsten oxide into grams of tungsten oxide, which was our goal from the start. So I arrange all the units like that so that I can cancel them out. Here we can cancel out grams because they appear in the diagonal. And here we can cancel out moles of H2 because they appear in the diagonal. And next, I can cross out moles of tungsten oxide, and that leaves me with grams of tungsten oxide. So now we just have to plug in the numbers. So our starting number was 250.0 grams of H2, and 2.016 grams of H2 are equal to 1 mole of H2. And 3 moles of H2 go with 1 mole of tungsten oxide, and 1 mole of tungsten oxide has a mass of 231.84 grams. So that is our setup. Now we're going to times on top and divide down. So the way that we punch this into the calculator is we take 250 times 231.84 divided by 2.016 divided by, again, 3, and then we hit enter. Notice we only hit enter at the end. So one more time, it's 250 times 231.84 divided by 2.016 divided by 3, enter, and we're going to get a fairly large number here, 9,583.3. And we're not too worried about how you're rounding here. We'll specify that on the quizzes and tests. Okay, good luck with these. Thank you for paying attention.